Yo, what's up everyone, it's Kalyan and welcome back to the channel. Today, we're diving deep into the world of ethical hacking and building some seriously cool tools using Python. Now you might be thinking, ethical hacking? Is that even legal? Don't worry, we're talking about the good kind of hacking. The kind that helps companies and organizations find vulnerabilities in their systems before the bad guys do. In a world where data breaches are becoming increasingly common, having top-notch cybersecurity skills is more important than ever. Think about it. Every connected device, every website, every app you use is a potential target. That's why ethical hackers are in such high demand right now. They're the digital detectives, the guardians of the internet, making sure our digital lives are safe and secure. So, if you're ready to level up your cybersecurity game and learn how to build some powerful tools with Python, then buckle up, hit that subscribe button, and let's get started. Alright, let's kick things off with a classic tool in any ethical hacker's arsenal, the port scanner. This tool is fundamental for anyone looking to understand the security landscape of a network. Imagine your computer network as a house with multiple doors, each door representing a port. Just like a house, some doors are meant to be open, while others should remain closed for security reasons. A port scanner is like that friend who knocks on every door to see who's home. It systematically checks each port to determine its status. It helps you discover which ports on a target system are open and listening for connections, giving you valuable information about potential vulnerabilities. This is crucial for identifying weak points that could be exploited by malicious actors. Now let's fire up our Python interpreter and build a simple port scanner. Python is a versatile language that's perfect for this kind of task. First, we'll import the socket library, which is our trusty sidekick for network programming in Python. This library provides the low-level networking interface needed to interact with ports. Next, we'll define a function called scan_port that takes the target IP address and port number as input. This function will be the core of our port scanner. Inside the function, we'll create a socket object and use the connect_x method to attempt a connection to the specified port. This method is non-blocking and returns an error indicator instead of raising an exception. If the connection is successful, meaning the port is open, we'll print a message saying so. This feedback is essential for understanding which ports are accessible. Otherwise, we'll mark it as closed. Knowing which ports are closed is just as important for securing your network. To make our scanner a bit more user-friendly, we can wrap it in a loop that iterates through a range of ports, say from 1 to 1024, which covers the most commonly used ports. This way, we can automate the scanning process and save time. And that's it. With just a few lines of Python code, we've built a basic port scanner that can help us identify potential entry points into a target system. This tool is a great starting point for anyone interested in network security and ethical hacking. Next up, we're tackling a topic that's both fascinating and ethically complex: password cracking. This is a subject that sits at the intersection of cybersecurity and ethical hacking, and it's crucial to approach it with a clear understanding of the boundaries and responsibilities involved. Now, before we dive into the code, it's crucial to understand the ethical implications. Ethical hacking is all about testing and improving security systems, not exploiting them. Password cracking should only be performed on systems you own or have explicit permission to test. This ensures that your actions are legal and ethical, and that you're contributing positively to cybersecurity. Unauthorized access is a big no-no and can land you in serious trouble. Legal consequences aside, it also undermines the trust and integrity that are foundational to the field of cybersecurity. With that said, let's explore how to build a basic password cracker using Python. Python is a versatile language that's widely used in cybersecurity for its simplicity and powerful libraries. One common technique is a dictionary attack, where we try to guess the password by systematically trying out words and phrases from a pre-compiled list, also known as a dictionary. This method relies on the assumption that many users choose common or easily guessable passwords. Python's itertools library comes in handy here, specifically the product function, which allows us to generate all possible combinations of characters within a given length. This can significantly speed up the process of finding the correct password. We can then loop through these combinations, hash each one using a cryptographic hash function like SHA-256, and compare the resulting hash to the hash of the actual password. Hash functions are crucial because they ensure that passwords are stored securely. If the hashes match, bingo, we've cracked the password. This moment of success is a testament to the power of computational techniques in cybersecurity. Of course, this is a very simplified example. In reality, password cracking can be much more complex and time-consuming. Real-world password cracking can involve much larger dictionaries, more complex algorithms, and even specialized hardware. High-powered computers and GPUs can significantly reduce the time required to crack a password. But the fundamental principle remains the same: leveraging computational power to test different password combinations until we find the right one. This principle is at the heart of many cybersecurity practices. Remember, the goal here is not to encourage malicious hacking but to understand how password cracking works so we can build stronger defenses against it. By understanding the methods used by attackers, we can better protect our systems and data. Chapter 3. Network Sniffing. Unveiling the secrets of data packets. Ever wonder what's happening behind the scenes when you're browsing the web, streaming your favorite show, or sending an email? Every action you take online generates data packets that travel across networks to reach their destination. That's where network sniffing comes in. It's a technique used to monitor and capture these data packets as they move through the network. It's like having X-ray vision into the flow of data packets across a network. You can see the invisible streams of data that make up our digital communications. Using Python, we can build a simple network sniffer that captures these packets and reveals their hidden secrets. This allows us to understand the underlying data structures and protocols. We'll be using the Scapy library, a powerful tool for packet manipulation and analysis. Scapy simplifies the process of crafting, sending, and dissecting network packets. First, we need to put our network interface into promiscuous mode, which allows it to capture all traffic passing through, not just packets addressed to our machine. This is crucial for comprehensive network analysis. Next, we'll use Scapy's sniff function to start capturing packets. This function is highly customizable, allowing us to specify exactly what kind of traffic we want to capture. We can specify filters to narrow down the traffic we're interested in, such as filtering by protocol like HTTP or DNS, or by IP address. This helps in focusing on relevant data and ignoring unnecessary noise. Once we've captured some packets, we can then dissect them using Scapy's built-in functions to extract information like source and destination IP addresses, port numbers, and even the payload of the packet. This detailed analysis can reveal a lot about the network's activity. This information can be incredibly valuable for network troubleshooting, performance analysis, and even security auditing. It helps in identifying issues and optimizing network performance. Imagine being able to see all the websites a particular device is visiting or identifying suspicious traffic patterns that might indicate an attack. This level of visibility is crucial for maintaining network security. That's the power of network sniffing. It provides deep insights into network operations, helping us to secure and optimize our digital environments. Chapter 4. Web Vulnerability Scanner. Exposing the weak links in your website. Websites are often the first point of contact between a business and its customers, making them prime targets for hackers. That's why web vulnerability scanning is crucial for identifying and fixing security holes before they can be exploited. And guess what? We can automate this process using Python. Common web vulnerabilities include SQL injection, cross-site scripting, also known as XSS, and file inclusion vulnerabilities. For this example, let's focus on SQL injection, which involves manipulating user input to execute malicious SQL code on a website's database. We can build a basic SQL injection scanner in Python using libraries like request to send HTTP requests to the target website and Beautiful Soup to parse the HTML responses. Our scanner will look for specific patterns in the website's responses that might indicate a vulnerability. For instance, if we send a request with a single quote in a parameter value and the website returns an SQL error message, it could be a sign that the website is vulnerable to SQL injection. Of course, this is just a very basic check. Real-world SQL injection scanners are much more sophisticated, using a variety of techniques to bypass security measures and test for different types of vulnerabilities. Chapter 5. Visualizing network traffic with Wireshark. Mapping the digital landscape. Alright, we've covered a lot of ground so far, but no ethical hacking toolkit is complete without Wireshark. Think of it as the Swiss Army knife of network analysis tools. It's incredibly powerful, and while it's not strictly Python-based, it complements our Python tools perfectly. Wireshark allows us to capture network traffic in real time, providing an incredibly detailed view of what's happening on our network. We can then apply filters to focus on specific traffic, inspect individual packets, and even reconstruct entire conversations between devices. But here's where things get really interesting. We can take the data captured by Wireshark and visualize it using other tools like Google Maps. Imagine plotting the geographical locations of IP addresses we've captured, creating a visual map of our network traffic. This can be incredibly helpful for identifying patterns, tracking down the source of malicious traffic, or even just getting a better understanding of how our network is being used. Wireshark's ability to capture and analyze network traffic, combined with the power of visualization tools, gives us a whole new perspective on our digital world. It's like having a bird's-eye view of the digital landscape, allowing us to see the connections and patterns that would otherwise remain hidden. Unlock your inner ethical hacker, and there you have it. We've built a solid foundation for your very own ethical hacking toolkit using Python. We've covered everything from scanning ports and cracking passwords, to sniffing network traffic, scanning for web vulnerabilities, and even visualizing data with Wireshark. Remember, with great power comes great responsibility. Always use these tools ethically and legally. Now I'm curious to see what you guys can build with these tools. Share your projects, ideas, or any cool tools you discover in the comments below. And if you enjoyed this video and want to see more content on ethical hacking, programming, or anything tech-related, hit that like button, subscribe to the channel, and turn on notifications so you don't miss any future uploads. Thanks for watching, and I'll catch you